Okay, so now let's talk about some basic statistical concepts. So first, we need to get some ideas about the so-called population and the samples. So a population is what? A population is a collection of persons, objects, or items, or whatever things that you are going to study. And if we are going to study some kind of population, typically what we do is some kind of census. That means we investigate everyone, everything in that whole population and get some numbers, and then we know everything about it. In many cases, that is impossible because we may have too many consumers to do the survey. We may have too many future things that may not be able to be accessed. So in that case, we're going to talk about samples and sampling. A sample is a portion of that population, or technically you can say it's a subset. And the sampling is the process to investigate just a subset of your population. Okay? And then based on the ideas we get from the sample or the sampling process, we're going to get some information, and we're going to use that sample to infer or guess something about the population. So here are some examples. If we have a population that is all the students in NTU, then some kind of sample would be we stand somewhere in NTU and ask 100 random students who passed in front of us. That's a sample. Or we can say, if we are talking about all the students in the business school, then that can also be a sample of all the NTU students. Okay? Because that's also a portion of all the NTU students. But in another study, maybe all the students in the business school are actually a population. Okay, if we want to understand, for example, what they will happen after they graduate, then that can be a population. In that case, all the students who are in the GMBA program or in the IM department can be a sample. If we are talking about a manufacturing situation, then all the chips that is made in one factory can be a population. Then a lot may be a sample. Okay? And if we are talking about all the consumers who have purchased some kind of products, we want to understand how they like our products or dislike our products, then again, we can do some survey, and according to whoever respond to your surveys, that's a sample. So if we have populations as our target and the samples as the persons or as the items that we may get accessed, there can be two important questions. The first question is, why do we want to do sampling? And the second question, of course, is our sample representative? So the two questions are the following. First, if we are able to do a census, there's really no reason to do sampling. Sometimes it's possible. Like today, we have some kind of new technologies that we can get to access to all the persons, all the consumers, all the items we are going to do investigation. If that's the case, then you don't need sampling, and somehow you don't need statistics. That's possible. But still, there are just too many situations that we need to do sampling. Okay? Then the second question would be, is our sample representative? Like, suppose my research topic is that I want to understand what's the available monthly expenditure amount that an NTU student have in average. Okay, I want to know in average is a student can spend $30,000 or $3,000, whatever. I want to know in average what's that number. Then in that case, if I go to the GMBA program and say, okay, MBA guys, tell me how much money you may spend in NTU for each month. That sample can be biased because MBA students are typically working or have some work experience. So in general, they are richer than typical students. Those students who are 18 years old, 19 years old, they don't have work experience. Okay, so obviously we need to worry about the representativeness of our sample if we are doing sampling. There are also two different kinds of statistics that we need to know. The first type is called descriptive statistics. If we are doing descriptive statistics, that means we have a set of data, and then we want to do some graphical or numerical summary of our data. Basically, that just means we want to describe a set of data. That's why it is called descriptive statistics. Sometimes we also call it exploratory data analysis, which is a process that we need to go through before we really do some deeper studies. Okay, so that's descriptive statistics. In most cases, we care more about inferential statistics because that's really the process for us to make some kind of guess on something that we don't know. Or technically, we try to say something based on our understanding about the sample to our population. Based on our understanding about sample, we want to make some guess about our population. And we hope our guess can be scientific. We hope that when we say, I guess for my population is this, or that, either we may know whether we are right or wrong, or whether we may estimate the probability that we are right or wrong. So that's the thing we want to do in inferential statistics. So here are some examples. Suppose I randomly select 1,000 students in NTU and I calculate their average height. Okay, the first guy 170 meters, the second guy 160 meters. I collect that 1,000 numbers and calculate the average number. Then in that case, that's descriptive statistics. I just do a numerical summary of that set of data. Okay, and then if I use that particular number to make an estimation to the average height of all the NTU students, if I do that, then that's inferential statistics. Because all the NTU students are here, I just get 1,000 numbers, and I say if these 1,000 students, their average height is 170 meters, I'm going to say, okay, then I guess for all the NTU students, it should be roughly this number. That's a guess. I'm not sure whether I'm right or wrong, but all I can do is to make that guess, right? Then I want to understand, well, there may be some bias, there may be some errors. I need to be able to have a way to quantify that potential error. That's inferential statistics. So here is another example. Suppose I'm doing some kind of pharmaceutical research. Then the potential patients, all of them, would be my population. I want to understand if they take my medicine, then what will happen to them. I certainly cannot do a census because there are just too many potential patients and some of them will show up in the future. I have no way to access them. So in that case, all I can do is to get a group of randomly selected patients. I let them take my medicine, take treatments, and I see some result, and then use that result to infer the result on the population. So certainly we need some kind of statistics or scientific ways to do that. Otherwise, we cannot trust all the drugs that we may purchase from the market. And then we need to get some ideas about parameters and the statistics. So what's them? A numerical summary of a population is called parameter. So that means for a population, if we get some numerical summary, that number is called parameter. Like the average height of all NTU students, or the expected coffee demand when the price is $50. So if we are talking about population, then that's talking about parameters. On the contrary, if we are talking about a sample, then whatever numerical summary we have is called a statistic. Okay? In this case, this is a particular item, particular number. Statistics is the field. Okay. So like If we are talking about all NTU students, then all NTU male students can be a sample. Their average height would be a statistic. Or if we are talking about all the potential demands, daily demands, when my coffee is about $50 per cup, then in that case, if I look at the past 6 days, that's a sample. Then the average coffee demand per day would be my statistic. Okay? We almost always use our statistic to do some inference to our population or to our parameter. Sometimes it's good, sometimes it's bad. That's something we need to tell you in this course. So here is a quick example. If we want to talk about the average height of all the NTU students, while a census is possible, it's still quite costly. So it's very natural to sample some NTU students and then calculate a statistic and just use that statistic to estimate the average height, which is the parameter. So some samples and statistics may be good, some may be bad. For example, I may randomly get a classroom and say, okay, I want to do the sampling. So here you are my sample and I'm going to calculate your average height. If I randomly go to a classroom and do that, that may not be a very good idea. For example, if I go to a GMBA classroom, the proportion of foreign students is higher than the general NTU students. Okay, there may be some bias according to that. If I go to a classroom where all the students are male, or most of them are male, that's possible, then there can also be some bias. So in that case, maybe what I should do is that I should randomly draw 100 students and get them and get their average height. That may be a better idea. Okay, or if I get 100 students randomly, there is really no one says that I need to calculate their average height. I can also take their maximum height, right? I can also get their sum, or I can get whatever I like and claim that number is the population height. But obviously we would say, the average seems to be more reasonable because we are talking about average heights. What's the point of using that 100 students maximum height to do the estimation? So all of them are statistics, but some are good and some are bad. In this case, using average is of course more reasonable than using, for example, maximum or sum. Finally, if we actually know that the NTU students in general has about 60% as male students and 40% as female students, if we know that, then when we do the sampling, why don't we just get 60 male students and 40 female students in our random sample? If we control that sampling process, then we are able to do that. And then we will be able to make a more accurate estimation in most cases. Then in that case, we would say this particular sample may be better than that random 100 students. So lastly, we need to give you an idea. A population is there. A population is fixed. So the parameter would be also fixed. For example, the average height of all the NTU students. You know all the NTU students are there. At the moment that you want to do a survey, they are fixed. So that particular number, the average height, is also fixed. There's really no reason that that number would fluctuate, right? But it's there. It's just that we don't know. We don't know what that number is, so we need to do some estimation. On the contrary, a statistic is generally a random number depending on the sample, because we typically randomly select 100 students, 1000 students, and today we get a sample, tomorrow we get another sample. The two samples can be different, and in most cases that's different. So in that case, we would get two different random samples, and that would generate two values of statistics. So that's why we say a statistic is a random number. Before you do the sampling, you really have no idea who will show up in your sample. So you cannot predict, you cannot see what will be your statistic. before you do the sampling. Okay, so that process has some randomness inside, and that's basically why we need probability when we are talking about statistics. Okay, the sampling process of course matters. So here are some basic concepts, and in the later courses we will talk about more about them.